Okie doke. All right, I think this is going to work. So if you guys would, for a second, give your attention to me here. Okay, so I have a setup here on how to collect data for Beakman's motor. So here is a device I have. This thing right here looks like this. This is called the Lab Quest. I'll see this. This is the data processor that we use. We can plug any kind of probe into it that we want. You can measure temperatures, motion, voltage changes. We can put microphones in and test sound, magnetic fields. There's all kinds of stuff we can do with it, and all kinds of stuff we would have done with it if you would have been here all year. But today what we're going to do is we're going to measure voltage. Now, in the Beakman's motor, as the loop rotates, there are voltage as it comes around and turns on. The voltage that it's measuring actually drops to 0. The battery by itself should be around 1.4. I mean, I know a D cell ideally is 1.5, but in reality, there's some resistance in the battery, and so the useful voltage that you get out is about 1.4 or something. Okay. So there is something called a back EMF, and we're not going to talk about that. It has to do with electromagnetic induction. But it basically, as the current goes through and creates a magnetic field, that magnetic field actually creates a voltage that goes backwards to cancel out the original voltage. And so that drops the voltage down to 0. And then as it turns off, then there's the voltage across the 2 terminals of the battery goes back up to whatever the battery was. That's not super important information for you. But what is important is that as it rotates, you can graph it going up and down, up and down, up and down, and every up and down is a rotation. Okay, so let me get my motor working here. All right, so that's going. Now, over here, I have the Lab Quest attached to a program on the Chromebook called Graphical Analysis. And I can hit the collect button here, and you can see all those up and downs. Okay, so, and then it just stops after a while. My motor actually is still kind of going, but anyway, the point is that I can now count every one of these peaks as a rotation. So if I want to know how fast it's going, I can let's say this went for 10 seconds and then it kind of tailed off. So that's bad data right there. I'm just going to pick a section. I'll say 4 seconds, and I'll say it went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it rotated 24 times in 4 seconds. So that's data I would write down. So when you write your experiment, you'd say, collect your data, and then how many rotations were there per second? So 24 divided by 4 would be 6 rotations a second. Okay? All right. And I would do multiple trials of that. Again, you watch this, it literally, if I'm only collecting for 4 seconds, I can do 10 trials, and that, legit should take me 5 minutes. Okay, so the data collection itself shouldn't really take that long. I will have things set up for you starting on Monday, maybe even on Friday if you feel like you're that far. I doubt there won't be that many people, but you'll be able to just take your Beakman's motor, plug it in, and then you can hit collect, and then you can take your data, put it down in your data table. And then ultimately what you're going to be comparing, what your dependent variable will be that speed. Okay, so what will you change in order to make the speed change? I'm going to add magnets on and see if you know, and see if the speed increases. I think it will, okay, for a hypothesis. Or I'm going to, instead of using a battery, just crank up the voltage on the power supply. I'll have a setup available for you to do it that way. If you want to use different loops with more turns or longer length, you can do it that way. So anyway, those are all options, and I'll have different setups available for you to do the kind of experiment you want. If you think of something different than that, you're like, hey, do you think it'd be possible for me to do a lab like this? Talk to me about it, and maybe we can set it up, okay? So that's what we would start at the beginning of the week next week. If you're a distance learner, tell me, I'll give you 3 options of what to do, and then I will provide the data for you. There is one other option. Okay, and this was sent to me the other day by one of my students in a different class. And what he did, he was at home and he set up his Beakman's motor and he used his phone and turned it on to slow motion. And he did it that way. So he knew, like, I don't know, he went for 10 seconds or whatever on slow. And then you know how many frames per second there are. And so I think for like the iPhone 8 and above, you can get 240 frames per second, which I believe is 1/4 speed. And so if you do it for 10 seconds, it should give you a 40-second video. And then you can count how many times it spins on that video. And then just remember that it's not 40 seconds, it's 10 seconds. And then you can figure it out that way. So that's an option as well. So if you want to do it a different way, we've never done it that way before, and that was a good idea. So I thought if you guys are into that, you can try that too. Distance learners and people who are here. Okay, the setup itself, I'm not going to get super technical with you right now. We can talk about that when we get closer to it. But I just wanted to show you, this is how we know how fast it goes. All right, that's all I got. Carry on.
What was that thing called again?
This?
Yeah.
A lab quest. All right, so distance, folks. If you guys have any questions, you can go ahead and type them in the chat. Otherwise, you are free to just continue working on your introduction. But again, please ask questions as needed.